I'm Tony Cricenti. I've been at Swinburne for, I don't know, close to 30 years. So, sorry? Since the Cretaceous, yeah. My connection to the other talks, I suppose. But yeah, so my talk's a little bit different. So I'm going to talk about the department that I'm chair of, which is what we call TERBo. And we called it TERBo because we think we're sort of a turbocharged group. We're heading forward in a fast sort of rate of knots. But what does it stand for? Telecommunications, electrical, and I always stutter when I say it, Robotics and Biomedical Engineering, right? So where are we? Where do we fit in the university? Well, obviously we're part of FSET, and we belong in the School of Software and Electrical Engineering, which is a big group. I don't know, we're probably about 50, 60 academics in the school. The other department is CSSE, so they're sort of the computer scientists and the software engineers. TERBo, we're the other engineers. All right, so we're a multidisciplinary group of academics. I think we've all got a sort of a common link of electrical engineering, but that gets a bit nebulous and grey too. I learned a lot about my department by trying to get some statistics and information about what we do in the group. But at this stage, I'll say we're sort of roughly electrical engineers. We're about 30 academics ongoing, and about 10 sort of research staff. That's about to change. We're getting a couple of new positions through the Women in STEM fellowships, so I'm looking forward to that. And as we were talking, or as the presentation was going, I got an email from Sarah wanting me to meet up with the new fellows, so that's great. But we're roughly divided up, although these boundaries are also a bit nebulous. But telecommunications, we look at essentially these days network communications, although we do look at a little bit of the old traditional communication systems. Electrical, probably things like renewable energy these days, the sort of the power grid system, and how we get that to function reliably, and that's a really topical sort of area these days with what's happening in the news, especially in South Australia. The other group is robotics. So here we get a nice sort of crossover with mechanical engineering, and we run a course that I'll talk a little bit about later that involves both areas. But this is actually using automation, not just in industry, but also in society in general, which probably we'll see more and more of going into the future. And biomed. These aren't in any particular order, but it's just the way I ended up putting them on the thing. I think it spells out TERB. So biomed, again, we've got some really good research happening in the biomed area, and we've got some research groups and centres that I'll talk a little bit about later too. All right, so teaching. Our main area of teaching in the undergraduate area is Bachelor of Engineering. We run 4 majors in that course. So I've only written BEng, but there's the professional as well. So the majors are biomedical, electrical, electronic, robotics, mechatronics, and telecommunications. So essentially they line up with the 4 major disciplines in the department. The other course we have a lot of students in is, and a lot of input in, is the Bachelor of Computer Science. And there we look at network design and cyber security. And cyber security, again, very topical these days with all the WikiLeaks, disclosures about the CIA, cyber warfare and that sort of stuff. So again, very topical. Also, we run 3 masters by coursework programs. So Master of Engineering Science, which is sort of the next step from the Bachelor of Engineering, I suppose. So a bit more in-depth specialist knowledge in electrical and electronic engineering. The other 2 courses are closely related: Master of Engineering Science, Network Systems and Telecommunications, and Master of Science, Network Systems. These are really big courses in terms of international student numbers, so we get quite a bit of income into the faculty through these particular courses. The size of the department, we're roughly 17% of FSET's taught load, and that translates to about 220 undergraduate students and 120 postgrad students. And we offer about 80 units in total. Right, so we teach a lot of units in the department, and a lot of our units are taught into many, many courses. We have some really specialised labs that we're proud of. There's what we affectionately know as the Cisco networking lab, but it's really our networking lab, and this is a lab that runs across 2 rooms. We've got about 200 networking devices in the lab, and we've developed software to allow students to effectively configure devices remotely, and we can run exams in there that are automatically marked. So we've spent a lot of effort and time getting automation into that laboratory. The other thing is it's a great research facility. Having 200 devices means you can build huge networks, right? And we can probably build a network the size of a small country in that lab. The other lab of note is a machines lab, and when I first started at Swinburne, in the machines lab we used to have motors that were about that big. Now they've been reduced in size to smaller desktop machines, but it does allow us to do experiments and work with machines, with power, even some renewable stuff, type experiments. And the third one's robotics, which is just upstairs. If you walk by, you'll see there are a lot of robots. Again, students use those to do various tasks. The other thing that I'm proud of from my department is we run study tours, and this is where students can go overseas for a period of time and get involved in some activity there, and they get credit for these things. So one of them is, I've got 3 there, but one's not a study tour actually. But last year we ran one to Malaysia, and the year before, and last year to United Arab Emirates, and we plan on running those things again. And we get about 15, 20 students going on these study tours. Scott reminded me, we also go down and take students to the synchrotron, and that's part of biomedical imaging. So, yeah. Outreach. I've just got a couple of the outreach activities that we do. A big one is the schools program. We either receive students here and run activities with them, or we actually go to schools and do similar sort of thing. But we're involved in the National Instruments Autonomous Robotics competition, and we won in 2012, but unfortunately we haven't been able to repeat that. We've managed to get second place the last 2 years. Hoping we'll win this year again. We're also now getting more involved in the Formula SAE. The car is electric now, so it's probably a good thing that the electrical engineers get involved in that project. So we're starting to do that this year. We've run what's called the first Lego League, and this is a little robotics competition using Lego robots for primary schools. And just today I got a letter from a student from Glen something primary school wanting me to sponsor them because they won the first Lego and they're going to the US. So that's a pretty good achievement. And BrainSTEM, we're also involved in BrainSTEM, so secondary school students working on projects to try to promote STEM there. Okay, research. This is where I learnt a lot. I had a look at our performance in ERA, and we ended up with a couple of 4s that are definitely you can definitely say belong to our department, and that's electrical engineering and communications technologies. And we got a 3 in distributed computing. But then I looked at where we got 5s, where the university got 5s, that's materials, nanotechnology and optical physics. And a lot of the staff from the department show up in those areas, so great contributions to those Era 5 rankings. Recently we've had a few new strategic appointments in the area of networked control, and so I'm guessing that will strengthen our Era performance going forward. I experimented with these, I forgot what you call these word things, but yeah, these word clouds, and it actually struck me that we also do research in the non-traditional areas that you probably wouldn't attribute to my department or our department here, but you can see we've got contributions not just to the things on the left-hand side there, but things like psychology, economics, and some cellular stuff, but areas that probably weren't in the forefront of my thinking, but that's good. It means we collaborate with lots of different groups around the university. We're in the process of trying to create some new labs in the department, but what we currently have there are the ARC Training Centre in Biodevices, and this is doesn't involve just our department, but other departments in the university, and Professor Paul Stoddard runs that, and they've got some great, interesting projects there. And this is where we get PhD students to get involved with industry, and actually their projects lead to some hopefully useful device or technique that can be commercialised. We've got a new group that's run by Grenville Armitage, and that's the I4T Research Lab. And this is, if you want, the technology that underpins the Internet of Things. So we call this the Internet for Things because it's the networking technology to support the IoT. The Intelligent Transport Systems, this is looking at traffic, vehicular traffic in cities or in an urban environment, and we do a lot of projects with BIC roads in that space. And finally, the ANFF BIC Bio Interface Engineering Hub, and this is where we build, or we have facilities to build nano devices. And I had some notes here to remind myself of some of the equipment that we've got there. But we've got things like spectroscopic ellipsometers, multi-vessel dip coders, Lamure blodgett troughs, and other things that I've got no idea what they are, but they sound impressive. And finally, this is a small list of the sorts of projects that are happening in the department. There are many, many more, but I've kept it brief. But we are collaborating with DST on testing this Hawk Mark 127 fighter. So there's my contribution to the military theme. Okay, if you're interested in any of these research projects, we can talk about it later. All right, so that's it for me. I don't want to put everyone to sleep too quickly. Thanks.